Welcome to the DIY Honda Garage channel. The DTC P2100 and P2118 indicate a throttle actuator current range or performance problem in the Honda CR-V 2023 and newer models. The throttle actuator is a critical component of the electronic throttle control system, responsible for regulating the airflow into the engine based on the driver's acceleration input. In essence, it translates your accelerator pedal movements into the precise amount of throttle opening to optimize engine performance and efficiency. When the powertrain control module, PCM, detects irregularities in the throttle actuator's performance over a specified time, it logs this diagnostic trouble code, DTC. Identifying the underlying issues associated with this error code is essential for ensuring optimal vehicle performance and safety. The error related to DTC P2100-01 and P2118 primarily concerns the throttle actuator, which regulates air intake for combustion engines. When parameters for the expected current range deviate, or when the performance of the actuator is deemed abnormal, the PCM records these deviations as DTCs. The PCM, or Powertrain Control Module, is situated within the vehicle, controlling various engine functions. It monitors data from a variety of sensors, including those in the throttle actuator circuit. The throttle body is often located near the intake manifold, connecting to the engine's air intake system. In assessing this DTC, critical components include the throttle body, external wiring circuits, MTR1, MTR2, and SG3, and the PCM itself. The possible causes for the DTC P2100-01 and P2118 include multiple scenarios that can affect vehicle performance. First, a malfunctioning throttle body may result in abnormal readings or failure to respond accurately to throttle demands, leading to performance issues. Secondly, wiring issues such as short circuits, breaks, or grounding problems in the MTR1, MTR2, or SG3 circuits may disrupt communication between the throttle actuator and the PCM. Lastly, a failure within the PCM itself could lead to incorrect readings or control signals being sent to the throttle actuator. Each of these potential issues needs to be thoroughly investigated to resolve the DTC. Symptoms associated with DTC P2100-01 and P2118 typically manifest as disturbances in vehicle performance. Drivers may experience poor acceleration when attempting to increase vehicle speed, since the throttle actuator may not respond correctly to pedal inputs. Additionally, warning lights on the dashboard may illuminate, signaling to the driver that there is a critical issue needing attention. Inconsistent throttle response can also occur, leading to a frustrating driving experience as the vehicle may hesitate or respond unpredictably when accelerating. Recognizing these symptoms is crucial for the timely diagnosis and repair of any underlying problems. The first step in troubleshooting DTC P2100-01 and P2118 involves confirming the vehicle's operational state. To initiate this process, turn the vehicle ignition to the on mode, ensuring that all dashboard lights illuminate, indicating that the electrical systems are activated. Following this, slowly press the accelerator pedal to the floor. This step is essential as it allows the throttle actuator to report its current state and functionality to the PCM. Observe if the PCM registers any abnormalities during this activation, as it plays a crucial role in monitoring the actuator's performance. If issues are detected, they may be recorded in the DTC registry, guiding further inspection steps. Step 2 involves inspecting the throttle body to ensure that it functions correctly. Start by disconnecting the throttle body connector specifically the 6P male terminals. Once disconnected, the next procedure involves examining the internal circuit of the throttle body. The specifications for normal conditions indicate that the resistance should be between approximately 1.2 ohms to 1.0 kiloohms when in the off state. An inspection yielding results outside this range could indicate that the throttle body is faulty, necessitating replacement or repair. This step is vital for confirming the operational health of the throttle body and eliminating it as a potential cause of the DTC. The third step focuses on inspecting the external circuits linked to the throttle actuator. Begin by ensuring the throttle body connector, 6P, remains disconnected, along with the PCM connector B, 101P. This disconnection is crucial for safety and accurate testing of the wiring. Perform thorough inspections on the NTR1 and NTR2 circuits to confirm there are no short circuits. Normal conditions dictate that the internal resistance should exceed 1 megaohm. Additionally, examine the SG3 wire for any signs of an open circuit, which must display a resistance less than 1 ohm. Any readings deviating from these standards can indicate wiring issues that may interfere with actuator performance and lead to DTCs being logged. The final troubleshooting step involves inspecting the powertrain control module, PCM, for any faults. After confirming that previous components have passed inspection, the focus turns to the PCM itself, which should remain functional for overall vehicle operations. If all previous inspection items indicate normal conditions and the DTC persists, this suggests that the PCM itself may be the source of the problem. The PCM controls various systems and sensors, so abnormalities in its performance can manifest as DTCs. If determined faulty, replacement of the PCM is necessary to restore functionality, ensuring the electronic throttle control system operates correctly. After completing the necessary repairs and inspections outlined in the troubleshooting steps, it is essential to verify that the repairs are effective. Begin this vital step by clearing any diagnostic trouble codes, DTC, stored in the system, specifically those related to P2100-01 and P2118. Use the Honda Diagnostic System, HDS, to remove these codes from the PCM. Following this, conduct a test drive under varied driving conditions to ensure the throttle actuator responds accurately to accelerator inputs without generating new DTCs. This method confirms that the resolved issues no longer impact the vehicle's operations. Observing consistent performance post-repair signifies successful remediation of the error codes. To reduce the likelihood of encountering DTC P2100-01 or P2118 in the future, implementing preventive maintenance is crucial. Regular cleaning of the throttle body can ensure it operates smoothly without debris or buildup that can lead to performance issues over time. Additionally, routinely checking the wiring connections associated with the throttle actuator can help identify any wear or damage early, preventing failures before they occur. Inspecting connectors and circuits periodically supports the overall health of the electronic throttle control system. Lastly, following the manufacturer's guidelines for maintenance can ensure that all system components, including the PCM, remain in optimal condition, thereby enhancing the vehicle's performance. In conclusion, effectively addressing the DTC P2100-01 and P2118 requires a clear understanding of symptoms, potential causes, and diligent troubleshooting practices. Recognizing the importance of the throttle actuator and the PCM in vehicle performance is paramount. Each troubleshooting step helps isolate the source of the issue, whether it originates from the throttle body itself, the wiring circuits, or the PCM. Once repairs are made, the final verification step ensures that functionality is restored and that no new codes arise after testing. By adhering to routine preventive maintenance practices, drivers can significantly mitigate the chances of encountering these issues in the future, ensuring reliable and optimal performance of the Honda CR-V. Please like and subscribe to the channel. See you next time.